All right, so this is our last section of chapter 9. So we're still talking about functions. So if you remember last time we saw function notation, so that was the f of x. So now we're going to talk about polynomial functions and operations that we can do with them. Let's start off with a definition of what a polynomial function is. So a polynomial function is a polynomial in one variable with one or more terms. So remember, a polynomial doesn't have to have more than one term. It can just be a single term. That's a monomial, which is just a specific type of polynomial. And it's written in descending order. So that's kind of standard form. It's not required unless they specify write it in descending order. And by that, we mean by power. And so a polynomial function is going to look, and this is going to look kind of weird because we're going to have a bunch of letters here, but we're going to have f of x. Remember, this doesn't have to be f, it could be g of x or h of x, and we'll see all of those today. So we're going to have f of x equals a n x to the n. So this just means it's our first coefficient, a n, and then x to some exponent n, plus a n minus 1. So these are subscripts, they're little numbers in the bottom, or on the bottom of the letter, and then x to the n minus 1. So notice how we're decreasing the exponent, we're writing in descending order, plus we're going to go all the way down to a sub 1 x, and now I'm not putting x to the first, because remember x to the first is the same as just x. And then lastly, we have our constant at the end, which we, in this case, call a sub 0. So this is our constant. And just to see an example of this, we'll have f of x equals, let's say 2x cubed minus 4x squared plus 3x to the first, and then minus 12. So this is a polynomial function. These are polynomials on the right side here, or this is a polynomial. These polynomial functions will all contain polynomials of some sort with one variable. So you're just going to see x's, or it could be y's. Most of the time it'll be an x. And it's written in descending order, meaning the exponents here go down every single time. And that last one is our constant. So that's what we're going to be working with. And first thing we're going to look at here is something we've been looking at before. And this is something we actually saw in 9.2. We're going to do it just a little bit more with polynomials this time. So evaluating functions. And let's go ahead and just look at an example here. So for this example, we're told to evaluate the following for f of x equals negative x squared plus 5x minus 11. And so part A, we're told to find f of negative 1. So now, because we got a little bit of practice with this last time, I would go ahead and try these three by yourself and then check your answers. So part B will find f of 0. Part C will find f of 1. All right, so now remember what we're doing is this number inside the parentheses is replacing x. So we're going to replace both of these x's here with our first value, which is negative 1. So remember for this part, you're going to leave this negative out in front. If it were a number, you'd leave that number out in front. You can always think of this as negative 1 if you want. Now I'm going to put our negative 1 in here for the x. And I'm going to put that in parentheses, and we're squaring that. And then we're going to have plus 5 times x, so 5 times -1, and then minus 11. Now, if we go ahead and simplify, remember that you want to simplify your exponents before you multiply. So that's this part right here. So -1 squared, or -1 times -1, is 1. So now we have a -1 times 1. And then I'll bring over the rest to this and we can simplify it all at once. So now if we go ahead and do our multiplication, we have -1 times 1 is -1. 5 times -1 is -5, so I'm going to put a -5, and then -11. And then lastly, -1 minus 5 is -6, -11 is -17. So when we plugged in -1, we got -17. And so this means, so this is kind of like the y value, this -17, because we plugged in -1 for the x. Now let's do the same thing with the 0. This one's a little bit nicer because working with zeros is generally pretty nice. So let's go ahead and leave that negative in the front, or you can think of it as -1. I'm just going to do a negative this time. And then we're plugging in a 0, so we're going to have 0 squared plus 5 times 0. Oops. And then -11. Now, if we go ahead and evaluate our exponents, 0 squared is 0. The opposite of 0 is still 0, so that's our first term. And then I'm actually going to go ahead and multiply in this step as well, because 5 times 0 is just 0. And then -11. Now these zeros just kind of disappear, so we have 0 plus 0 is 0, -11 is -11. That's the nice thing about plugging in a 0, is those x terms just kind of disappear and you're just left with the constant. Now let's go ahead and try the same thing for 1. So again, I'll leave the negative in front, and then we're plugging in 1. So we have a 1 squared plus 5 times 1 minus 11. Now, if we go ahead and evaluate the exponents, 1 squared is 1, and then we have the negative out in front. So that first term is a -1. And again, I'll go ahead and multiply in this step because it doesn't affect, it doesn't make a difference if we do it now or later. So plus 5 times 1 is 5 minus 11. And going left to right, -1 plus 5 is 4. And then 4 minus 11 is -7. Okay, so again, that's a little bit of review from what we saw last time. Now let's go ahead and look at operations on functions. And in general, this stuff isn't usually too bad. It's just some arithmetic and making sure you distribute negatives from time to time, but it's not too bad. So let me list out the operations first. So first thing we have here is f plus g in parentheses of x. So remember, this doesn't mean multiplication. This means we're going to add our two functions together. And so this is the same thing as f of x plus g of x. You're literally taking the two functions and just adding them, so we'll be combining some like terms. Same thing if we have f minus g of x. This means f of x minus g of x. Our next one, if we have fg of x, this means you're multiplying, so f of x times g of x. And lastly, f over g of x is the same thing as f of x over or divided by g of x. And for this one, Notice how the F is on the top in our original notation, and it's on the top of this one. The order does matter for division and subtraction. For addition and multiplication, doesn't matter the order. So make sure you're just kind of sticking to that order every single time. That way you won't mess it up on the ones where it matters. All right, so let's go ahead and just look at some examples. And we're just going to run through a bunch using the different operations. This first set of examples, we're given f of x equals 3x squared plus 8x minus 6, and g of x equals negative 4x squared plus 4x minus 8. We want to find, so we're going to do two things. First one, we're going to find f plus g of x. And then second one, we're going to find f minus g of x. All right, so again, looking at what we have up top for our little definitions up here, f plus g of x is just what we get when we add the two functions together. So let's go ahead and add f plus g. And so what we're going to do here, I'm going to put them in parentheses, and this part doesn't really matter when you're adding. Subtraction, it will matter because we're going to be distributing that negative. So our first polynomial in parentheses is 3x squared plus 8x minus 6 plus our second polynomial, which is negative 4x squared plus 4x minus 8. Now, all we're going to do here is, because we're adding, if you remember back in, I believe it was chapter 5 of Math 95, we're going to combine like terms. So we're going to have 3x squared and then plus a negative 4x squared. So that's going to give us negative 1 or negative x squared. Then we'll have 8x plus 4x, which is going to give us a positive, so plus 12x. And then finally, negative 6 minus 8, or negative 6 plus negative 8. That'll give us a negative 14. And this is all we're doing for these, just combining those like terms. Okay, let's go ahead and try the same thing with subtraction. So again, we're taking f, subtracting g, so make sure you keep it in this order. So f of x is, in parentheses, 3x squared plus 8x minus 6, and now minus negative 4x squared plus 4x minus 8. So this is one where, depending on how your professor kind of went through this, you can either kind of distribute this negative into all of these terms. That's one way of doing it. But what I like to do is, remember back when you were adding a negative, or sorry, you're subtracting a negative. So say we had 5 minus negative 3. In order to add these, we can add the opposite, and so it becomes 5 plus 3. So what we're going to do here is we're going to use this concept over here. So we're going to add the opposite. So I'm going to change this to addition, and then change the signs of the polynomial that comes after the subtraction sign. So remember, over here, you only change the sign of that negative 3. You don't touch the 5. So over here, we're going to make this a positive 4x squared, a negative 4x, and a positive 8. That way you don't kind of forget to distribute that negative. And now it's just like the one we just did. So let's combine like terms. So we're going to have a 3x squared. 3x squared plus 4x squared. It's all positive now. So that's a 7x squared. And then we'll have an 8x plus a negative 4x. So think of that like 8x minus 4x. That'll give us a positive 4x. And then lastly, -6 plus 8, that's a +2, so +2 at the end. So like I said, these ones are pretty nice. And the next set of examples, we're going to be doing something similar, but we'll also be evaluating the functions. So in this set of examples, we're given f of x equals 18x squared minus 24x, and g of x equals 3x. We want to find f plus g of 1. So now we're finding f plus g of a specific value, and f minus g of 1. Okay, so first thing we want to do here is you want to first find f plus g of x, and then we're going to plug in x equals 1. So let's go ahead and do that. So if we go ahead and find f plus g of x, well, we're going to have f, which is 18x squared minus 24x, plus g of x, which is 3x, and you can put that in parentheses, but you don't have to here because it's just a single term. And now let's combine like terms. We only have one like term to combine, and we'll leave that 18x squared in the front. So we'll have 18x squared, and then negative 24 plus 3 is negative 21x. Now we're going to take this and we're going to plug in 1. So f plus g of 1 is equal to 18 times 1 squared, so that's our x, minus 21 times 1. All right, now if we go ahead and simplify, 18 times 1 squared, we need to square this one first. 1 squared is 1, so we have 18 times 1 minus 21 times 1. I'll multiply in the same step here. These are nice though. 18 times 1 is 18, minus 21 times 1 is 21. And then subtracting those two, we get -3. So f plus g of 1 is equal to -3. Now, we could have also gotten this answer by plugging this 1 into this very first step here before we combined our like terms. Totally doable, you'll get the exact same answer. There's just some more work going on here. There's more terms to combine, and it's a little bit more work. So I always like to simplify first and then plug in the number. Okay, let's go ahead and do the same thing with this one here. First thing we're gonna do is find f minus g of x. So if we do that, we're gonna have f, which is 18x squared minus 24x, minus our g of x, which is 3x. Again, you can put parentheses, you don't have to. Now let's go ahead and combine our like terms here. And if you want to change this to adding the opposite, we have a plus -3x, you can do that. But again, it's a single term, so it doesn't matter as much. Let's keep the 18x squared in the front, and then -24x plus a -3x is -27x. And now let's find f minus g of 1 by plugging in 1. So we're going to have 18x squared, so 18 times 1 squared minus 27 times 1. Whoops. And then simplifying this down, 1 squared is 1, so we have 18 times 1 minus 27 times 1. And so 18 times 1 is 18, 27 times 1 is 27. So we have 18 minus 27 gives us a negative 9. So f minus g of 1 is negative 9. All right, so that's addition and subtraction. Now let's go ahead and try some multiplication. So again, we're given f of x equals 2x plus 7. And g of x is x squared minus 4. And we're told to find part A, f g of x. And then part B, we're told to find f g of 2. So notice how to find f times g of 2. We have to find f times g of x first and then plug in 2. So that's nice. The first step kind of takes care of that for us. So now doing kind of like what we did up here with addition and subtraction, except this time we're multiplying f times g. So f is 2x plus 7. G is x squared minus 4. So I put both of them in parentheses right next to each other because we're going to multiply them out. And now you want to make sure that you simplify because the questions will ask you to simplify these. And so in order to do that, we're going to FOIL this out. So we'll do first, outside, inside, last. Or just remember, you're just distributing these terms. So the 2x has to be multiplied by the x squared and the negative 4. Same thing with the 7, it goes to the x squared and the negative 4. So 2x times x squared, remembering your exponent rules here, we have an x to the first times x squared gives us x cubed because we add those. So we have 2x cubed. And then 2x times negative 4 is negative 8x. And then moving on to the 7, 7 times x squared is just 7x squared, so plus 7x squared. And then 7 times negative 4 is negative 28. And if we go ahead and combine our like terms, if we have any, well, we have a 2x cubed, a negative 8x, a 7x squared, and a negative 28. So none of those are actually like terms, so we could leave it just like this. If the problem on my math app specifies descending order, what you're going to want to do is put them in descending order based on the exponents. So 2x cubed goes first because x cubed is the highest exponent. Then the 7x squared. Then the 8x, so minus 8x. And then the constant without the x at the end. So again, if it specifies descending order, use the second one. If not, this first one is actually perfectly fine. It's just not our standard form. All right, now we want to go ahead and find f times g of 2. So what we're going to do here is we're just going to plug in x equals 2. So if we take our polynomial, we have 2x cubed. So we're going to have 2 times 2 cubed plus 7x squared, so 7 times 2 squared minus 8 times 2, and then minus 28. So I use the descending order version of this one. You could also plug it into this and you'd get the same answer. So we go ahead and simplify this. Again, exponents first. So 2 cubed, 2 times 2 times 2 is 8. So we're going to have 2 times 8 plus 7 times 2 squared is 4. And I'm going to leave this subtraction until the next step because then we can do all of our subtraction at once. So we have minus 8 times 2 minus 28. So now our multiplication, we're going to have 2 times 8 is 16. 7 times 4 is 28. 8 times 2 is 16. And minus 28. Now, I want you to notice something about this one because we have a 16 and a minus 16. So those guys actually cancel each other out. And we have a 28 and a minus 28. So those also cancel out. So what is our actual answer for this one? Well, if we added all of this up, 16 minus 16 is 0. 28 minus 28 is 0, so we just get 0. That one isn't typical. You don't typically get 0 as a solution, but it's totally possible because we're just doing arithmetic here. Okay, now let's try a problem with division. So here we're given f of x equals x squared minus 6, and g of x equals 3x. We're told to find part A, which is f over g of x. And for this problem, we also want to say what x cannot equal. So we'll talk about why we have to do that after we plug it in. Move that down a little. Part B, we're going to find f over g of -1. So just like we did before, we're going to take our f over g of x and plug in -1. And then lastly, we're also going to find g over f of x. All right, so let's go ahead and start with f over g of x. So for this one, see how we have f over g. We're doing division, so we're going to have f on the top, so x squared minus 6 over g of x, which is 3x. And now if we look at what we have here, if you remember from Chapter 7, if we wanted to simplify something like this, we would need to factor and see what we can cancel out. The only thing that's potentially factorable is on the top, but 6 is not a perfect square, so this is not the difference of squares. And so this actually can't be factored and simplified. So this is our final solution. So this one, a lot of the times these are really fast because they can't be simplified as easily. But we do have to see what x cannot equal. So this is also a Chapter 7 thing. So if you remember, we can't divide by 0. So our denominator here is 3x, and that cannot equal 0. So you can either say 3x equals 0 and then solve for x, or put cannot equal 0, and same thing. Let's divide both sides by 3. We get x cannot equal 0 divided by 3 is still 0. So this is also something you'll be doing in the homework. You're going to have to say what x cannot equal. And this only happens in these division problems because we end up with a denominator. But in multiplication, addition, and subtraction, we just had a, we didn't have fractions. We didn't have any x's on the bottom, which is why we have to specify here, but we didn't have to specify before. Okay, now let's go ahead and try to find f over g of -1. So f over g of -1, we're going to plug this -1 into our f over g of x up here. So we're going to have x squared. So we'll have -1 squared minus 6 all over 3 times -1. So simplify the top and the bottom separately. So -1 squared is -1 times -1, which is 1 minus 6 over, now 3 times -1 is -3. Doesn't matter if you do multiplication on the bottom before you do it up top, because that's the only thing we have to do in the bottom. And we evaluate the top and the bottom separately. So now simplifying the top, 1 minus 6 is -5 over -3. And this isn't quite simplified because a negative over a negative is a positive. So we get positive 5/3. All right, so the last little part here is to find g over f of x. So I put this one in here because I want you guys to really pay attention to what order they have stuff in. Same thing goes with subtraction. On this one, they have g on the top, f on the bottom. So for this one, we're going to put g on the top, so 3x over f of x, which is x squared minus 6. So be careful with, I'll say the order or placement of f and g. Okay, so then our last problem we're going to do is an application problem, and I want to show you guys this one, and then I'll have you kind of simplify it down and finish it up because it is on your homework, so I don't want to do the whole thing for you. But let me go ahead and get this one up for you guys. All right, so this is our application problem. And again, this is the same as the last problem on your homework for this section. It might be talking about something other than baseball caps, but it's the same kind of idea. So we're told that the cost to produce X baseball caps is C of X equals 4.3X plus 75. And the revenue is R of X equals 25X. So first thing they want us to do is find an equation P for profit in terms of X. So what we're looking for here is the profit as a function of X. So we're going to have P of X. Now, profit is what you get when you have, it's all the money that you make. So we have to subtract the cost from the revenue. So from the total amount that they made from these baseball caps. So we're going to have R of X minus C of X. And so then what you're going to want to do is you're going to want to take R of X, which is 25X, and subtract, now I'm going to put this in parentheses because there's multiple terms, 4.3X plus 75. So the big thing for this one is to remember to simplify. So the only thing you have left to do, besides maybe change these numbers because your numbers are probably a little different, is make sure that you, for one, distribute that negative and then combine like terms. So you'll have to finish this one up, but that's what you need to do for this one. And then for part B, we want to find the profit if 50 baseball caps are produced and sold. So for this one, we want to find if we have 50 baseball caps, well, baseball caps are the X's. So what we want to do here is find P of 50. And so then what you're going to have to do for this one is you're going to take that 50 and plug it into what you get up here for your profit equation. So you're going to plug in, I don't know what that was supposed to be, plug in 50 for P of X. Sorry, let me write that a little bit better. For X in P of X. From part A. All right, so that's how you are gonna work through that last problem. And we're done with chapter 9. So our next chapter is chapter 10. We're gonna be talking about radicals, so like square roots, cube roots, all of those. These are tricky, and the sections are gonna be kind of long, as is the chapter. But once we get through that, we only have chapter 11 and we'll be done.